Good morning, students. This is a simple short video dealing with one of the important theorem or rule known as the Gauss theorem or the Gauss rule, which says about the character. Character means the nature of the roots of a polynomial equation. Strictly speaking, it tells about the existence and non-existence of imaginary roots depending upon the missing number of coefficients in a polynomial equation. So let's have that rule or theorem. The Gauss rule: if all consecutive terms are missing in the polynomial equation, f of x is equal to x raised to n plus a n minus 1 x raised to n minus 1 plus etc. plus a1x plus a naught equal to 0, then there are two cases. Then fx has at least r imaginary roots if r is even. If the missing terms is represented by r, number of missing terms is r, and if r is even, this will have at least r imaginary roots. And if r is odd, f of x has at least r minus 1 or r plus 1 imaginary roots, according as the preceding and succeeding terms have like or unlike signs. Like means both of them are positive or both of them are negative. Unlike means one is positive, the other one is negative. Means preceding and succeeding means, see, totally r terms are missing. So just before that it is preceding, and just after the missing terms we will have succeeding. If the symbols, looking at the symbols, you can decide that will have either r minus 1 if they both of them are unlike terms, and r plus 1 if they have unlike terms. Like or unlike signs. So this must be unlike or like. That should be changed as unlike or like. Means, let us have an example. Illustration: consider x square plus 1 equal to 0. We already know that this has two imaginary roots. Let's verify the Gauss rule for this equation. Here one term is missing. Which term is missing? Coefficient of x is missing. Therefore, there is one term. One is actually an odd number. And the signs of the preceding and succeeding terms are here. This is the preceding term of that x, and this is so they are like. So like means there will be r plus 1, r plus 1. So this must be unlike or like. R plus 1 comes for like terms. Therefore both of them. Therefore it has r plus 1, which is two imaginary roots. At least here two imaginary roots. We know there are exactly two imaginary roots, I and minus I for this one. And in the case of x square minus 1, here also 0 x is missing, but the coefficient of x square is 1 and coefficient of x square is minus 1. They are unlike. Therefore there are r minus 1, at least r minus 1 imaginary roots. Therefore r minus 1 is actually 0, r is 1. Therefore 0 imaginary roots. That means both of them are real. Now let's have a question based on the Gauss rule. If the coefficient a or only one coefficient is missing in the polynomial equation f of x equal to 0, which is of degree n, and if the coefficient ar plus 1 and ar minus 1, the values are multiplied, means it is greater than 0, means both of them are positive or both of them are negative, show that f of x had at least at most n minus 2 real roots. So it talks about real roots. The Gauss rule talks about imaginary roots. So look at, only one term is missing. This is not the r that is referred to in the Gauss rule. Here one is missing. So the number 1 is odd, and this, as I already mentioned, this means that the succeeding ar plus 1 is succeeding coefficient, ar minus 1 is preceding coefficient. Both of them multiplied will be greater than 0, means either both of them are positive or both of them are negative. That means they are like terms. Therefore, using the Gauss rule, that there must be at least r plus 1 or 1 plus 1 imaginary roots. So at least two imaginary roots means the remaining roots must be at most n minus 2 real roots. So this is the problem which we do using Ligard's rule. So the importance of the Ligard's rule is that it gives some idea about the existence of imaginary roots depending upon the number of missing roots are there in the equation. So that's the thing. So thank you all for watching this video.